And I think we are back. Let's just see here. Got to get through this commercial. I don't know about these advertisements. They might be cool and all, but hold on. Oh, is that why? Is that why you did that? Okay, seems like we are what I like to call live. Let's see if we can get a. Oh, yeah, turtles all the way down. All right. Okay. So welcome back, guys. So sorry, and gals. Oh, goodness, I need to break myself of that habit. You can't be saying things like that, Ian. So where we left off, we have this wonderful async thing going. Let's get rid of these silly little files. We don't need them right now. Delete and yes, kill that buffer, my friend. All right, so we'll just make sure not to save this. Well, I mean, we're going to end up saving it anyway. So there's a couple things here. This is going to get real disgusting if we do this and keep doing these chains and these maps and all these bits like that. Hey, welcome everyone. Welcome Austin Girl and S4 Codex. Are you guys still here? Oh, yep, perfect. Welcome. Thanks for coming. I don't know how exciting this is going to be, but hey, it might be fun. So let's move all of this stuff. We have all this nasty going on. Let's move all of this into helpers so that way they're not crowding our space. Hey, Muhammad, how are you doing? So to do that, let's first take this read async, and really we're just going to be working with JS files here. So R comes after P, so let's do const, and we'll do read JSON. Make it nice and simple, easy to follow, and we will take with this, we'll make it a function that takes in a file. And I mean, we could put file name, but why do that, right? The other thing we're going to want to do is bring in async from Crocs. So we will add that to here. And we'll just put all of this stuff inside of here. So for this, what we'll return is this guy right here, or this thing right there. Oops, 2DD. And what else are we going to do? We want to take this chain. So we'll do from node, and then we can call that directly. What's the best way to do this? All right, so what we'll do is just do what we did before. Let's just move this whole thing over. We'll make it. All right, so now we have our read async, and what we're going to do is for this file we will read async, and we'll do file, and since JSON's always text, we can go ahead and have that. So now that we have this, we can take that and push this in there, and all we'll do is chain that. All right. So basically we're just going to clean this up, make it a little more generic. Real boring stuff. Please stick with me. I promise it's going to get a lot more exciting. Let's move this up here. And we want to bring in all of this stuff. So we'll bring that stuff there. And what is the other thing we need? We want this. Oops. Yeah, we'll get rid of that. We want this. Okay, that'll do the read file, read async, and then our read JSON. This will be our result to that. Then we have parse. We don't need to export parse anymore because that's going to be used internally. So here we can do just read JSON. All right, so now we have read JSON in there. And that's just going to use read async, do that, and this of course will do our error handling for the result to async function. So that will be good there. We can take parse off of here now. The only thing, so we want read JSON, and we'll bring that in, and then we can replace this with, don't need to do that anymore. This will just be read JSON, and we just need to pass in the file name. So we will do, what is that, D to that. Okay, and we can get rid of all this stuff for now. We don't need all of this gobbledygook, gobbling up our goop. We'll remove omit, don't need that, and don't need that. So we have our read JSON. Now we need to go ahead and do our write JSON. Okay, yeah, don't mind the errors. Mind the precipice, I guess. So we'll do our read async. We need to bring in our write async. Okay, and that will go here. And then what we want to do is capture this write async, right? So now we'll do const write JSON. All right, so now write JSON is going to take two parameters. So let's go ahead and curry this. So write JSON is equal to curry, and we need to bring curry in from here, QRST, so that should go there. Okay, and what is the other one? Curry, so we'll do curry. We'll bring curry in. So now what we want to do is we will curry on file and data, and all we need to do now, so we have that, we have that. Why is this complaining? Because of what you're doing, that's why. So now that we have that, we have our file as the first parameter, and then our data for our data last type stuff. And we want to call write async, and we want to call that with file, and we want to write out, let's see here, we'll take whatever our data is and we'll JSON.stringify it, and we'll stringify data and null, and of course our two spaces, so we get our nice pretty JSON there. All right, now the other thing we need to do is we want to maintain our data flow. So we're going to make this act like a tap, right? Because the write async is actually going to return us an undefined. And undefined isn't good because it doesn't let us pick up our chaining. Like we can't chain, like we lose our data. Like there's nothing we could do with it because it goes away. So we want to keep our data integrity and keep that chain. That's the problem with a lot of these side affecting functions, is like console.log returns the actual log, like the how would you say, it returns undefined. It doesn't return the values that were sent to it, because how could it? It's a you can put multiple parameters to it, so how would it be able to do that? Anyway, we have control over that now because we have this here data, and since we're not going to do anything to it, we can do the same sort of stuff and capture our map here, right? So we'll do our map, and then here we'll bring in constant and return data. All right, so we need to bring constant in, and O comes before U. So here we'll do Constantinople. Istanbul was Constantinople. All right, and now we have our constant. So we basically just moved this whole thing. Boop, boop, boop. All right, we moved all of those functions. We don't need async. We don't need constant anymore. We really don't need anything from Crocs, but let's just bring in pipe K because I know we're going to need it later, just so we have something here, right? Why not? Okay, so now we need to export our write JSON. And again, if you guys got any questions about what the heck is going on, things like that, feel free to hit me up in the chat. If you are here and don't have an account and can't get access to the chat and want to ask a question, I recommend getting it. You don't have to get the pro subscription, but just a normal subscription will allow you to chat and do things like that. Hopefully they didn't up me to a premium thing, because I'd be really bummed if there's a bunch of people that cannot see what it is I'm doing. That would kind of bum me out. But let's just see if this works. We need to do write JSON. All right, so now, oops, what are you even doing? All right, so now we have our write JSON, and all of this is good. So we took all of this bunch of like setup stuff and kind of the nasty like putting it together and chaining and getting our error handling, and we kind of were able to just squirrel that away somewhere. So that's the other benefit of these over a promise, is it's a lot easier to just build out different things that like work with different asyncs and stuff. And because they don't run all the time, like the second I create something, like it does with a promise, then it's a lot easier to extend these. So this is one advantage of these over a promise if you're ever using promises or things like that. I'm not saying promises are bad. They have their place, but they can do a lot of neat things. But a couple things I don't like about them personally is they catch errors and reject, and that breaks the functor law, as I've said before. The other things that they do is they're eager, number one. They're not lazy, so you can't do cool compositions or like put different things together. Promises are pretty neat, don't get me wrong. The other thing I don't like about them is you can pick up, like say I throw an error or something like that, and I put a catch in there, it still will continue on with any thens or anything after it. So the interface can make for a lot of trouble when you're trying to design like kind of a solid flow, where these types of data types or data structures, they, number one, obey the functor laws. Number two, they are lazy, so I can compose and reuse and do a lot of things with them that you just can't do. You can do it with promises, but you have to put things inside of functions. This basically takes all that boilerplate and does it for you, and just is able, it gives you an interface that you can then compose. So let's just see if this is still working. We'll try to read the data, and you know what, let's just get rid of this for now. I don't like seeing the red there. All right. So we have our read JSON, and we see that yes, it is reading our JSON. So now we need to make sure that we can actually write the JSON. So here we'll do chain, and we'll remember we curried that function, so we can take write JSON, and we of course need to bring that in. Okay, we take our write JSON, and we need to say what we want to output it to. So now we'll do output.json. Okay, so now all of the nasty stuff and all of the things that get this working nice is squirreled away in a place that I don't need to worry about it anymore. And now we can just work with these functions in really simple ways. And so let's see if this actually worked. Oh wow, I didn't get an error. That kind of makes me happy. So let's see if we wrote a file. We do have an output.json, and it did write it the way that we did. So we took that big old nasty file that we had, and we were able to take all of the building and construction of that and squirrel it away into some place. So now we just have these functions. And you know what I want to do with this read JSON? Because this read JSON takes, well, I guess it only takes one argument. And I only have that one argument. So never mind, we're good here. But now we have an acceptable interface. We have something that's going to work with our flows, and by doing this partial application, we're able to do this chain. Also, because we have the results and all that stuff in there, say we were to request a file that did not exist. In a world where this file doesn't exist, we will call this dat.json. And you see, instead of throwing an error, it actually rejects with the error. It doesn't actually throw the error and destroy our stuff. Well, I mean, because we're using the node bits, right? Like node just takes care of that, but this passes the error down and doesn't actually do the writing. So we got our error handling there. Um, and let's just make sure that all of the bits for improper JSON that we implemented last time is still working. So if I come over here and we'll just delete this line. Oops, nope, nope. All right. So we'll close that and let's open our data.json. So this is our source. And we'll go ahead and make this invalid JSON. And go over here and restart. And we'll notice it didn't actually throw the error and destroy our program. All it did was it rejected with our error. So we're good. We are good. All of our stuff is working. So now we have a really simple type of thing going on here. So I was going to show you, or I am going to show you, one of the neat things. So I've talked about this many times, especially in the last one. It's this function signature. This is like the most important function signature for all of this, right? So if we look at read JSON, helpers. So if we look at read JSON, and let's do one of these so that way everything is. So notice read JSON here. Let's put some signatures on these so you can kind of see what's going on. Oh, one thing I want to fix. Oh, it's already fixed. All right, so if we look at read JSON, this takes a string as a file name. So this is any A. In this case, this A is locked down to a string. It needs to be a string. It could be, I mean, it could be a buffer. It could be anything. But for our purposes, like if we look at what read file does, it could be a string. It could be a buffer. Or it could be a integer. These two represent descriptors, basically. So it could be any of these, but we're just going to lock it down to the string one. We still could pass that in. This is all just fake. Like I can pass anything to it, but I expect a string. I want a string. And when I do that, I'm going to give you back an async of error. Or let's see here. This is going to give back, once we read the JSON, an object. Right? So this is that signature. This is my A, because remember, A can be anything. So I'm taking a string, and I'm going to give back an async of either error or object. And that's what this B is. So it's more like this, but we tend to only care about the right-hand parameter, because that's what we're mapping on, that's what we're going with, things like that. So we just keep it A, M of B. So now let's look at this signature for write JSON. So this one's a little different because we've curried it, right? So this takes a couple things, right? So this is going to take an object of some kind. So first it's going to take the file name, and then it's going to take the data, which could be of any type. Because you can turn anything into anything but a function into a JSON. So if I can turn like a 1 or a true, or I can turn an array or an object. So because that is the way that it is, it will, we just put an A there because it could be anything. And if I get it back, I'm going to get back an async, and because we are doing this extra mapping here and going to pass the data, we're going to get back an A. So we pass back whatever it is. So in this case, we're doing objects because that's what our source file is. But if we put in an integer or something like that, it's going to get us back an integer. If we put in but it's going to be the same type of whatever A is. If this type differed, then and could be something different, like say it always gave back an object for an object. It always gave back a array for a number, any mapping, anything we want to map to. This is basically saying that this type could vary from whatever this type is. But by putting the A here, we're saying this type is going to be the same type. Whatever you pass in as A, because it's polymorphic, it's going to be the same type as that. So that's what we're saying here. And now if you look, this is such a beautiful representation of this A to M of B. So right now, this is actually a string to an A of M of B. In this case, it's going to B is the A. So this B can be anything, including an A, right? So for instance, over here, we're passing in, say we passed in an object, right? B still could be an A. It doesn't matter. B could, all this is saying is B could be something different than A. This is the same thing. It's the same signature, except this is saying it will always be the same type. But we're able to change types as we go through these flows. So, but that same B could be an A, if that makes sense. I know it's weird. Sorry about that. In this case, we have that same thing going on here. We have our string, and this is where an A turns into a B. So we pass this a string, which is a file name, and we get back an object, which is the JSON that we read in. If we don't have something from there, oh, and you know what? See, this should be an A. It's a good thing I caught that. Because what if we have an array? I mean, yes, an array is an object, but we like to specify that, hey, this is specifically an array. So anyway, these all match that signature. All right? It takes something and gives you back something. So what we could do to build this out, we could make a function, and we'll make this called flow, right? Okay, let me explain the K. Anyway, we're going to make this into a function, and we're going to do this with something called pipe K. Now, typically I like to use compose K or compose things, but when I'm doing flows like this that kind of look like a promise, usually it goes from top to bottom when you're doing this, dot, then this, then this, then this. And if we look here, we have our chains and our maps and our whatever, like it goes from a top to bottom. So when I'm building out flows like this, I kind of like to use the pipe operator as opposed to the compose operator. And I used to always use the compose, and then there's a fella at work that's also really into stuff. I saw him doing this like in flows where he was doing like async flows and stuff, and it just read better. So I decided to adopt his style. So before, you might have seen my stuff, I always used compose, and I was like, gotta use compose all the time. But I saw how effective this was, so I tend to set up these types of async flows as pipes now. It just seems to read a little better, like when you're going through the code, like next time you're you or whatever. Future you is looking at past you's code. So this K right here, see, I was talking about, what's this saying me? Oh, because I have to do this. And we'll do require from Crocs. Oh, and if you guys are curious, this is Crocs. This is the library we're using. It's just a library. It's a little library I wrote about with ADTs. It's got a bunch of stuff in it, like Crocs. These are the actual like data types we work with. It's got a bunch of monoids that we work with. It's got logic functions, so like these ands, and they take like a predicate function and predicates, or a pred object, a pred ADT, and lets you build out some pretty complicated structures. Then we have all these helper complicated logic statements. Then we have all these helper functions and stuff that just work with the library. One of the ones we will be using, though, is this pipe K. And what this K stands for, they're called Kleisli arrows. I'm not going to get into it too much, but that's what this right here, what this signature represents. So there's an actual category called the Kleisli category, and these are arrows inside this. Oh, I'm sorry. Hey, welcome back. Yeah, sorry about that, Dimitri. I moved, all I did was just cleaned up everything and took all of the nastiness that we had, and I just moved it over into this. Sorry you missed all that. I was just going to take a break for a half hour. So anyway, we have these Kleisli arrows, right? And that's what the K is. And it lets you, because of this structure, it knows, Kleisli, when you work with these, it knows it's expecting functions of this signature. So it knows how to hook everything up in the background. So I don't have to do like this dot chain and dot whatever. So we can get back the same thing just by putting in read JSON, right? So this will take our input file, since that only has, one attribute here. And then we can take this whole thing, delete to, or no, I want to delete F this. So now I can put this in, and remember, if we apply this string, like which we're doing here, it's going to get us back a function that matches the A to B, right? The A to M of B. This now will fit into a Kleisli arrow after we partially apply the string to it. So now with it partially applied, we should now get the same sort of flow that we had before just by calling flow. And remember, we need to bring in the name. So we'll do flow, and this is, what was our input? Was it input.js? Oops. See, what are you doing? I just like overwrote all of our helpers. What did I? Well, we'll find out really soon what it was I did. As soon as I save this. So that is data.json. So we'll do data.json. This is going to error because, oh, maybe not. I thought I destroyed something in there. Guess I didn't. All right, so now if we look, it still works. So now we don't have to do, now that we have these functions that match that A to B, we don't have to do all this like chaining and do this and do that and stuff like that. We don't really need to do that too much anymore. Now, since we were calling chain on it, we can do this. Okay, so now we have kind of an issue. So let's actually do this as, and we'll get the file name in there. So what we're doing here is I want to create a flow that has this stuff hard-coded in it. So this will basically take the, by doing it this way, it's going to ignore whatever parameter we pass it, and it's going to give us an async with the name in there, and then that's going to get passed on to read JSON, which is going to read from the file of that, and then it's going to do the output there. So we need to bring async and constant in. Okay, so now everything's working all hunky-dory, super peachy and wonderful, and things like that. But the issue we have here now is, say I want to have a different output. Maybe I want to output it to S3, or maybe I want to put it into a different file. Like, I don't always want to go to output.js. And say for my flow and whatever I want to do to it, I don't really always want to read initially from this data.json, right? So that's where a reader comes in. And there's actually, I'm going to go over and show you really quickly how we do this with the reader monad. But one of the things we don't have in Crocs right now, there's a couple things I need to get in, are these things called monad transformers, right? So it's basically, as we go through and build this with the reader, you're going to see we're going to have to do a lot of like hardwiring and a lot of like plugging things in and always making sure to chain on the async and do our operate. It's going to be a mess, well, not really a mess, but there's a lot of noise there that deals with the working on an async inside of a reader. reader. But that's where things like monad transformers come in. So we are in Crocs, there's things I need to do here. But there are things called transformers which will go ahead and run your it'll do all the hookup and everything for you. So when I call chain, I'm not calling chain on the reader. I'm calling chain on the reader of async. So I don't have to ever call chain on the inner workings of it. It just knows how to hook all of that up. Same with AP. Like all we're doing is we're running with it. Then we're going to call AP and pass in the result of the monad that was passed us. Things like that, right? So this handles all of this plumbing that we're going to have to do while we deal with the normal reader. So this isn't in Crocs yet. Like I said, there's some things I need to, some optimizations I got to get in, and a thing I need to add. So that way, what I want you to be able to do is do a reader T, and then say I want to wrap an async. I can just pass in the async constructor, and it should know and hook everything up. But right now, the async constructor doesn't know what algebras it implements, and I need it to be a monad. I can only have monads in there. So the way Crocs is set up now, I can only do that with instances of monads, but I want to do it with the type reference or the type representative, like the constructor that I'm using for this. So like I have to make those changes and get that in there with this implements thing that I'm doing. So as soon as we get a couple things in there, I've been toying with the idea of these transformers. So we'll have a reader transformer and a state transformer, because really what we're doing here, it's a lot nicer when you do it inside of a state monad instead of a reader monad. But I figured I'd start with reader, kind of show what that looks like, and then move on to something else, like, or show it with state, which is how you'd really want to do what we're doing here. But reader's cool enough. It gets you kind of the same thing. Okay, so what we need to do now is we need a way to capture these asyncs. We need a way to capture the values that are being passed in here. And we need a way to work with them in that way. So to do that, we're going to bring in a reader. And what a reader does, by the way, another side note, there's a guy, Jack, who? Oh my goodness, what is his name? He just did reader React component. Oh gosh, what is his name? He's really, he does some really good stuff here. Reader component. Gosh, I wish I knew. Is it Jax? Is it Sue? It's not Sue. Maybe it is who. If you guys know who I'm talking about, feel free to chime in. Oh man. Sorry, I'm not good with oh my gosh. I'll just search like a grandmother searches. There it is. Oh. Anyway, so this guy is amazing. He writes some really good blog articles, things like that. But he gives a good example of how to use a reader, and he's using it with React. That's the thing with this reader and like all these ADTs, is they can be used in any context or anything that you need to how would you say, that you need these embellishments or this these abstractions to work on, right? So anyway, this is a wonderful article. His whole blog is really good. And he does a lot with functional programming and monads and in React. And I don't know, I like the way he writes. He's a good guy. Anyway, sorry, I didn't mean to. I just like sharing that with people. So we're going to use a reader, and what a reader's for is letting you inject environment into something, right? So a lot of times people use readers with asyncs or futures or tasks or whatever you want to call them. These types of algebra or these types of ADTs or data types. A lot of people use them for, like, say you're doing a connects database or something on a back-end node job, right? So you always need to pass that connects reference around and all of this other stuff. But each of your functions need the same environment to run. Like, they need that driver to be able to call their queries on. Maybe they need some sort of authentication information that they need to complete their request with. Maybe they need something else, right? But it's something that's shared as an environment on every single request that you make. So instead of like having this async and injecting it in like in the file, like we could have a read users async that just reads the users, or an update user async that updates the users, or something like that. Well, what we can do is not inject and have connects everywhere, because that makes it really hard to mock. And like when you go to write these tests, I need to have some way to overwrite the global connects that's being brought in on the requires. But if I use a reader and I provide a connects to every single one of the functions in my inside of the async, then all I need to do is call run with and pass in a stub or pass in a mock or something like that into the reader. So then I can run tests to make sure everyone, like, it called connects.select, it called connects.whatever. So I can pass a mock in and not actually use it and just make sure that all of my calls are happening the way that they should be happening. So anyway, that's what reader's for. It's a way to inject environment into a flow. So let's see what we can do about this. All right, so we have all of these things. Now, when we do this, we're not going to be having a fork. We're not going to have it like do all of that stuff. When it's inside of the reader, the reader's, remember, everything here is lazy. So the reader is just going to build everything out the way that we want it and give us back our async that we can run at any time. So if you guys are ever into design patterns and stuff inside of object-oriented programming, there's a really good one called the, oh look, there's connects right there. There's a really good one called the builder design pattern, right? And you can use this with a composite to like build something out. So the reader isn't just a builder. Like, the reader is very generic, but we're going to use it kind of like this builder design pattern that you would use inside of an object-oriented language. So I would have some sort of manifest or something that builds something out and puts everything together. So we're going to have our environment data is going to act like the manifest or act like the data that we'll need to build out this complex structure that we're going to have, or our program. So don't think that reader is the only reason for it is to do this builder design pattern. It's so abstract and so generic that you can use it to implement something that resembles the builder design pattern. Like, you would, in an object-oriented approach, you could use this same pattern to get the same type of flow that we're doing. It's not to say that that's the only thing that reader's for. Reader, you can do all kinds of things, anything that you need something injected for, right? So let's just kind of see what this looks like. We'll play with this just for a minute, just so we can kind of get our feel around what reader's doing, right? So we have this function called ask, and what that's going to do is it's going to ask the reader, or it's going to ask for the environment. So if we want something that has the environment, and say we want to take the environment and we'll say grab something off of it, right? So I can do ask, and we'll use a built-in Crocs function called prop. R comes after I. So, and what prop's going to do, if we look here, prop, of course. So if we look at prop is going to be kind of like the Lambda prop, but it's more like the sanctuary prop. So it's going to get us back a maybe. So if it's there, instead of returning undefined, it's going to give us a maybe of A. So this is a curried function that first takes the prop or the property we want to pull off, and then it takes an object or an array, and from there it gets us back either a maybe of A. So if that is there, it gives us back the A as a just A. If it's not there, it gives us back a nothing. Easy peasy. So what we're going to do is we're going to ask for prop. Oh, come on. So we're going to take prop and we're going to put happy. So now when we have this, we can do m dot, and we want to log this. Wait, why did that? Oh, never mind. Okay, so we want to log this, and this has a function called runWith, and runWith is the environment that we want to do, right? So we can do m.runWith, and runWith is going to take the environment. So let's create a little something here that I like to call the environment. So we'll do const data is equal to, and we'll put happy, and we will put true, of course, right? So now we can do runWith, and we'll run with the data, and it's going to get us our just true. Now say we do it is happy, we get a nothing back, right? So that's how that works. So what's going on here is it's actually asking for it and doing the bits like that. So let's put this back. Now, the thing you might be saying, oh, who cares? That's just a function, right? But now, since we're getting back a reader, we can go and chain onto this reader, and chain is going to provide you, you have a way of getting the bits back. So the first function to this is going to be the result, or the first parameter to this is going to be whatever this came back is the result. Not the environment, but this would be true. So if we look at what this is, we'll just call this val. We'll go ahead and do something with that value later. You're going to see that's the result of pulling true from that. So what we want to do is put these two things together, I guess. Who knows? So we'll do sad just to see here. We'll do our sad. So we chain that in, and then here we'll do ask, and then here we'll get the environment again. And we're going to do something a little different, right? So what we want to do is take that val, because remember that val is going to be a maybe. So since it's a maybe, we can do a map on that. And from here, what's the best way to do that? Yeah, so we can take the map on that. What is the link? This... Oh, that's just a blogger that I like. He's a really cool guy. That's it. Yeah, I don't know him or anything like that. It's just I came across his blog like a few weeks ago, maybe a month ago or something, and I like reading it. He puts out some good stuff. So what we want to do now is we're going to have the result of this actually come back and give us back a, how would you say, we want it to give us back, what's the best way to do that? Yeah, so let's do a chain on this. So we're going to chain in, and this is going to get us our actual value x. So let's call this maybe. Okay, so this will be our val. He does a lot with functional stuff. I don't know if it's just with React. I know lately he's been kind of looking over that, but I don't know. He's been pretty good. He's been putting some good stuff out. I'm pretty impressed with it, if you ask me. All right, so what we want to do here is we're going to get a maybe back. We're going to do all that. But say we want to take the prop off of that. We're going to turn this into an array. And there's probably an easier way to do this, but this just shows you kind of like what's going on inside of there. So, and actually the beauty of this is because it's all pure, we'll just call this make array. That's all we're going to do. And make array is going to, you know what? We're not going to do that right now. That'll be an exercise later. So what we want to do is take the inner value from this, which is going to be from that maybe, and then we want to take the prop of that. So we actually have two calls here. Okay, so now we have sad. Sad's going to be the hold on. What is it I'm even trying to do here? So we get our maybe back, we do the ask. I had this whole thing thought out a little bit in my garage. I should have actually put the darn thing. So what we're trying to do here is we're going to take that maybe that comes back from pulling happy, and then we want to ask this. So we want to take the maybe from there, and we want to then ask that. So we could just do n. All right, let's change this up. So then we have an n. Let's do it this way. There we go. Okay, so now this is just going to pull sad off of that. That's going to do that. So now that we have that, let's go ahead and we can do our happy. Okay, and then here we want to chain in, and we are going to do our maybe. There we go. There we go. Okay, so now that we have that maybe, we have our little sad thing, which is going to, you know, bring that in. So now we can just do sad. Okay. Okay, so this will bring in x. Nope. Sorry, I had my order all wrong. This is why I hate working in the outside of the reader transformer. All right, so here We then want to take our sad, which is going to get us back that value, which is going to be a, what is that? A reader. So we need to return a reader. So now that we have the sad, we then want to map over that. And then this is going to be our sad maybe. So we'll do this S and we'll do this H. Okay. So now that we have that, we have our S, we have H coming in, which is going to be our happy. We have our sad coming in. So we're going to map this in. And what we want to do with this is come through and build in array. Oh, nope. This is what we want to do. So we want to use actual AP here to kind of bring these together. So we're going to do a lift A2. That's right. And we will do a maybe a 2 pair. Now we'll just do XY. And then this needs to be curried. Sorry. I thought about this in my head. And so this will be real simple. X, Y, and XY. Okay. So this will take the values of those and actually build it out. So we're going to need two monads here, or two maybes here. Sorry about this. So then we just do our ask, and, or not our ask, I'm sorry. We're going to do our happy. And then we're going to take our sad. Boy, I wish I wrote this up first. I hate figuring this stuff out while I'm all right, so now I take our sad, which is that, and what do I want to do here? Course. Oh, because people didn't bring lift A2 in, did they? Always forget about the applicative. Okay, so that came back as nothing because we don't have a sad. Okay, so sorry that took me so long to get through. But what this basically did was we have this happy. So happy is defined as a reader of let's see, what's the best way to do this? So it's going to be a reader of object to maybe of Boolean, I guess. Object of maybe and bool. Okay, this is also the same. So this is going to come back as a maybe a Boolean, or it's going to come back as, something else. Or nothing, I should say, not something else. It'll come back as nothing if it's good, otherwise it won't be, right? So we need to do, we could do a little other thing too. We can bring in option to extract that out, but right now we just have it's just going to return a just, right? So, I mean, what we could do is say option here, and we'll say option, sorry, Charlie. I want Charles in charge of me. So if that way, say sad isn't there, it comes back and does sorry, Charlie. Otherwise, we get the, whatever. Okay. But see now M's a little different, right? So M, even though both of these bring back a reader of object, because the object is the environment that we're expecting to be passed in to run. So these types are a little different. Remember with the sum types like a maybe or an either things, the left parameter is the failed state or the not good state. When you're dealing with function type stuff like IOs and async, well, async's a little different. But when you're dealing with things that can be composed, you just compose asyncs differently. But say I have a reader and an IO or things like that, or an arrow or a star, the thing on the left is the actual the thing on the left is the input to that function that you're wrapping, and the thing on the right is the result of that. So here we're saying that reader wraps a function that expects an object and is going to give you back a maybe a bool. So here we've changed that, right? So M, because we're putting everything together, M is going to expect an object. So it's a reader that takes an object and is going to give you back a maybe of list of booleans, right? If that makes sense. Okay. So what's going on there? Like I was saying, here we can do that. We'll put it back to sad. But now we can change all of this because we're using the reader. Like this prop, this isn't really, a good example, but it is kind of a way to show you that it doesn't really matter. It's just every time you call chain, you're going to get back in an environment of something, okay? So now this pair up, this is the part that's kind of strange. This uses an applicative. This is where the AP and all that comes into. But what lift A2 does, if we were to look at any of our lift functions, so what lift A2 does is it takes an applicative M, but it'll take for lift A2 a binary function that's curried, and then you give it an A and a B, and then it'll give you back an M of C. So basically it's just the maybe, that we're putting through our applicative. So we have our maybe of A, maybe of B. It just so happens that A and B are the same booleans. And then here the C that we get back is the maybe of array, right? So that's what we're getting back here is our just true true. All right, so we can change this by doing false or whatever. So now this just gives us different environments that we can build stuff into. So like if I want to do a string of this, even though this breaks the signature that I just wrote, we would need to change this to a maybe of A, and a Boolean of A, but it could vary. Like in this case, lists aren't tied in JavaScript to a function. Right, so now we get back a do not cry, but if sad becomes sadness or glee or something like that, we get a nothing back because we're expecting that. So this lift A2, this is basically the function that we're going to run, and why it's called a lift A2 is it lifts this function into the monad, or I'm sorry, into the applicative. It doesn't need to be a monad, but actually applicative of needs to have chain. It might need to be. Anyway, it takes the applicative and it will lift this into the applicative. So we give it here, we're talking about the applicative of maybe. So even though this isn't wrapped in the maybe or anything like that, this is going to lift this into the maybe category and allow other maybes to be applied to it. So then it's going to apply each one of those to it and then give us back a new maybe with the result of this wrapped in the maybe. So it lifts this entire function into the maybe category. We could do that with anything that's an applicative. So if we had an either or an async or something like that, it will take that function, put it up in there, and then apply any arguments to it, and then you'll get the result back. So what that means is I don't have to do any of that wiring up. What we're doing here, how the flow is working, is we take our happy, and then we do our chain on happy. And then from there, the chain, remember, needs to take an A to a maybe of B, or I'm sorry, an A to a reader of B. In this case, the reader of B is going to be the maybe of whatever. So it needs to match that. So sad, of course, as we have it defined here as a reader, because this is going to bring the reader back, we're now working with that reader, and we're going to map inside of that sad and pair it up. So right now the sad is the other reader that's there. So we're going to lift this paired up function and then partially apply H to it, which is the happy that came in, right? We're going to partially apply H to it, and then this is going to take whatever's inside of this sad, which happens to be another maybe, and it's going to apply the maybe as the last parameter there, which is going to get us the maybe back. So it's just a real simple way of capturing that flow. So that's kind of how this thing sort of works. I could have done other things, like say I wanted to stringify this, right? So here I could do dot map JSON.stringify. Oh, but here I need to do a map. So we need to do a map, and then we'll take M, and let's just do the, that's the bummer about working with things inside of things. M comes after L, so we'll just bring in the point-free version of map. And here we will map and map on X. Actually, we'll just do JSON.stringify. And turn this back to sad. So now we can keep everything string. See how it put it in there? But you'll notice it didn't do anything to this other one. And that's because it's a different chain. So we've asked for the environment here, and now we can build a complete chain out with that environment and then still use that, see how we're using it here, separate from this specific chain of stuff. So when we call ask here, it's going to always ask for the same environment, and this object will be passed to everybody that gets chained in. They will have access to this. Just by calling ask. Now, ask is basically a shorthand. You'll also notice if you look at other reader libraries, this is just something that Crocs does. So, well, I think some other ones do it too, but it's one of the flows that I favor. You'll notice that we're passing a function into ask. Well, and that's because most of the time when you ask, you typically ask then map. So instead of okay, I'm sorry. So the other ones, you'll get the ask back, but it just gets you back a reader, and then you have to apply your mapping or whatever you want to do to it. 9 times out of 10, I'm usually doing a map immediately afterwards. There are a few occasions where I don't want to do a map. I might want to do another chain or something real quick. But because that is the least, since I do that a lot less often in writing production code and actual like working code, not just stupid examples like this, I'm always mapping directly after that. I automatically, for my ask, you pass it a function and it's going to do the mapping and all that for you. Because say I were to do a, I think Fantasyland has a reader, a couple other ones have readers. I have to do this. I'm always doing ask, then map, then chain, then whatever, right? So instead of doing that, I just get rid of this and always map the first one. And then if I need to do a chain or something like that, then it's just a matter of actually, instead of using ask, just returning a reader, right? And building the reader out to accommodate that. So anyway, that's one thing if you use readers from other places that you'll notice is different than the reader that ships with Crocs. Okay, so now that we have all of that, is there any questions? I know this, I'm probably not explaining it very well. It probably seems like voodoo magic if you're not familiar with like applicatives or things like that, but this is basically how the reader works. It just lets you inject stuff into it. And it's going to, anytime I ask, I'm asking for whatever was passed to this run with function. So whatever you call with that, that's going to be what this is asking for. And every chain or every branch of your code will always get the same version. Now, this is JavaScript, and it would break laws if I were to change this and make it an immutable object. It needs to work exactly the same way that it would work if it was in normal JavaScript, right? So I don't implement immutability on these. So you could change the environment here because it is an object. It still is the object reference. But for me to give you a new object back, it doesn't flow right. It doesn't, that's not a thing in JavaScript. And when we're building these ADTs or these things, these algebras, it's very important that we do the things inside of them the same way JavaScript was. That way, if you have a better way of doing immutability, you can just inject your own immutability and it would work the same as if you injected it or used it inside of your normal application as it would if you used it inside one of these ADTs. And you, as the developer, chose to use that immutable library, or you chose for it to be immutable. So now all of your identities will match, or not your identities, but your compositions, and the identity law and things like that. It matches up, and you want to be very weary about some of these libraries that do things for you, like catch errors or at least in this context, or like give you back an immutable object. Now it's okay with like Lambda and things like that because that is in the JavaScript. They're not doing that inside of one of these functors. But if you're using a functor library, it's very important that you match exactly what they're doing, or the library author should match exactly what it would do if it wasn't running in here. So you don't want to do anything to any of the data that's getting passed through you. You only want to hook up, like when you're writing these ADTs, you only want to hook up the interaction between them. Anyway, just be very wary, and if you see things that are doing stuff to your internal data, it may not be a functor. And certain laws aren't going, you won't have a lot of the guarantees that you would have normally. Okay, so moving on, all we did here is we just took the data from this environment and we built out an array from it. It's totally pointless. No one really cares about this crap, so I'm getting rid of it. All right, so we will delete to G. Okay. So now let's do something actually real. What time is it? Oh, goodness gracious. How long have I been recording? It's already been an hour. I'm trying to keep these to an hour. Because I'm doing recordings and stuff, it's going to go with the series. So at this point, so sorry. I just explained the reader. Not much going on here. We didn't really do any of the cool JSON stuff. But again, I'm sorry, guys. I'm going to take another. I got to be very stringent about this. I'm going to take another probably 30-minute break, and then we'll have the final here. Now, also today, later on, I'll be starting a fantasy football Pick 9 application. I'm definitely going to finish this. This will be the next thing. So the next hour segment is going to be finishing this bad boy up and putting it all together and showing you how to use a reader like this with an actual async. I'll be doing that in about 30 minutes. And then after that, I'm going to take another 30-minute break, and we're going to start building I have 3 months to build a Pick 9 fantasy football league management system. Um, and I'm going to be doing a lot of cool stuff. There's this guy, Josh, I can never say his last name, Burgeis. Anyway, he makes this cool library called Most Redux. I'm a big fan of Most.js, one of my favorite stream libraries out there. And Anyway, I'm going to try using that on the front end. It's going to be a Redux app, but we're going to do, or a React app. But we're going to do both front end and back end, and we're going to set it up so it can be deployed on a cloud. So we're going to do all the Dockerization and all of that. So the first hour of that is going to be getting the front end. Oh, goodness gracious, I'm sorry about that. Is going to be getting the front end all set up. So we'll be building our build system for the front end. We should get that done probably in about 15 minutes to a half hour. And then we'll just play with it a little bit. I'll show you a couple things. And then the next hour after that is doing the back end. So getting Docker and Docker Compose and all of our stuff set up and bringing in a database and getting all that set up and working. Be sure to join me for those if you guys want to. I don't know what the policy is with all these changes, but until they tell me don't do it, I'm going to start recording these and putting them up on my YouTube channel. I don't know with this premium stuff, I don't like people being cut off from knowledge. So I'm going to at least post the results of these onto YouTube. My biggest fear right now is that they put me on a premium thing. Hopefully, I'm not that good, because then that keeps people from, like normal people, from viewing this stuff. That makes me sad. It seems, I don't think, no. Anyway, I have my own views on that. Although I do love the platform and I like what they're doing, I understand why they have to do this. I just need to make sure that you guys, as the learners, are not screwed. So that's what I got right now. I'll be back in a half hour and we'll finish this up and I'll show you the big payoff. Like, why would you want to use a reader with a async? And we're going to read in a JSON file, modify that, and write it to the hard drive, or write it to the file system. And yeah, that's all I got. So I will see you guys in 1/2 of 1 hour.